The diagram shows a triangular prism where the cross-section of the prism is an isosceles triangle, thus angles CDE and DCE are 45 degrees. In this special triangle, when the hypotenuse is x centimeters, the shorter sides are root 2x over 2. It is given that the volume of the prism is 3.6. The volume is calculated as the product of the cross-sectional area and the length of the prism. The area of the triangle is half times root 2x over 2 squared, and the length is y. Simplifying the equation, we find y equals 14.4 over x squared. The surface area of the prism includes 2 right triangles and 3 rectangles. The area of the triangles is x squared over 4, and the areas of the rectangles are xy, root 2xy over 2, and root 2xy over 2. Factoring out xy from the last 3 terms and substituting y equals 14.4 over x squared, we derive the expression for the surface area. S equals x squared over 2 plus 72 times root 2 plus 1 divided by 5x. In part B, we need to find the value of x that minimizes s. First, we differentiate s with respect to x. The derivative of x squared over 2 is x, and the derivative of the remaining term is negative 72 times root 2 plus 1 divided by 5x squared. At the critical point, the derivative equals 0. Multiplying the equation by x and rearranging, we get x cubed equals 72 times root 2 plus 1 over 5. Taking the cube root of both sides, we find x equals 3.26, rounded to 3 significant figures. To justify that this value gives the minimum s, we compute the second derivative. The second derivative is 1 plus 144 times root 2 plus 1 divided by 5x cubed. Substituting 5x cubed equals 72 times root 2 plus 1, and simplifying, the second derivative is 3, which is positive. Therefore, x equals 3.26 minimizes s. To find the minimum value of s, we substitute x equals 3.26 into the formula for s. The calculation gives 16, which is the minimum value of s, rounded to 2 significant figures.